Thank you for having me. Yeah. Hello everyone. My name is Sneha Muppalla. I'm a sophomore in Cupertino High School, and today I will be teaching the basics of the machine learning workshop. So this is the agenda for today. We're going to start off with an introduction of what machine learning is, give a few examples, and then I'm going to talk about the libraries that we're going to use for the demo later. Talk about why they're important, and then we're going to set up Jupyter Notebook, which is part of Anaconda, because Anaconda contains already built-in packages that we don't have to install ourselves. Another one would be, we'd also be going over algorithms we're going to use for the demo, which is decision trees. And then we're going to start the demo. And when there's more time, we're going to go over more advanced topics. So what is machine learning? Well, machine learning is a subset of AI or artificial intelligence, and it's one of the trending topics these days and will have a lot of applications in the future. So it uses data, lots and lots of data, and applies algorithms to imitate the way that us humans learn. So I'm going to give you an example. So imagine I ask you to write a program to scan an image and determine whether it's a dog or a bunny. So you might check the colors of that animal, maybe if it's like light brown, dark brown, but it can be quite difficult to differentiate based on the color. Maybe the shape of their ears, the shape of their eyes, the color of their eyes. So what I just explained right now are like some of the traditional techniques, traditional programming techniques, and it's going to be overly complex, right? So if we already created a program with these different if statements of checking their curves, the color of their eyes, the fur color, right, and it works really well, then if I put a new image of where the image doesn't have any color, it's just black and white, then you might have to change your method. You can't rely on color anymore of your of that image anymore. And if I give an image where the picture is rotated, rotated, then it's going to be difficult to determine the image based on certain curves or the shape of a certain part of the image. So this is going to be quite complex, and this is where machine learning comes from. Wait, sorry. 1 minute, something happened. Sorry, okay. So yeah, this is where machine learning comes from, and it's a technique to solve these kinds of complex problems. So we build a model or an engine, and we give it lots and lots of data. So in this case, we're going to give it lots and lots of images, pictures of dogs and bunnies. Then our machine learning model, will then find and learn patterns in the input data, so that when we give it a new picture of a dog or a bunny that we've never seen before, it can easily detect that image with a certain level of accuracy. And the more data we provide for the model, the higher the accuracy will be. So I just gave a small introduction of what machine learning is, I guess like how it is used in the real world. So now we're going to go over the libraries, right? So libraries contain inbuilt methods that we don't have to code ourselves. So we can import these libraries, apply their methods, and it's gonna make our code a lot shorter and easier for us to understand. So machine learning does use a lot of libraries, and I'm gonna go over a few of the more popular ones and the ones that we're going to be using later in the demo. So the first one is NumPy. it provides a multi-dimensional array, so it's easier for us to understand parts of our input data and images even. The next one is Pandas. It provides a concept called data frame, and it's a data analysis library. And it contains a concept called data frame. Data frame is a two-dimensional data structure similar like an Excel sheet. In Excel sheets, there's rows and columns like a data frame, and we can select data in the row or a column or arrange in rows and columns. It's very popular. The next one is Matplotlib, and it's another library that allows us to create graphs on plots based on our data. It's also, if you want to check the change in your accuracy, your training accuracy or testing accuracy, it's very useful, and it's a great way to visualize how your model is working over time. Then there's Scikit-Learn, which is one of the most popular machine learning algorithms out there. Machine learning libraries out there. It contains many common algorithms such as decision trees, which we'll be taking a closer look later. And Scikit-Learn contains mainly all the machine learning algorithms, even deep learning algorithms as well, such as neural networks. So we're gonna go get set up with Jupyter Notebook. So this is one of what I recommend what we're going to be using for the demo, and I highly recommend. Because Jupyter Notebook, it's very useful for frequently inspecting data, and it's very easy for us to understand, debug, and easy to read. And the reason we're doing it from Anaconda is because Anaconda comes with the libraries. So we don't have to manually install the libraries ourselves or any other packages because they already import it while we're installing Jupyter Notebook. So if we go to Anaconda, I will send the link in the chat. So I already have it opened here, but I will send it in case. So so if you're unable to access the website, I shared the link with you guys.
People will respond to that if they need any help.
I'm sorry, what?
I'm back in the chat if they need any help. So you can, I'll be watching and you will be watching. Yeah.
Okay. Yeah, so once you get to the website, you should see a button here below. So since I'm using a Mac, it automatically shows that I can just download the Mac version of Anaconda. But you can also download it if you have Windows, Mac, and Linux, Mac OS. So I'm just gonna click download right here. It's gonna show up. So it might take a few seconds, so we'll wait. Okay, so once it's done downloading, I'm just making sure, are you guys able to see the install Anaconda browser here? Yeah, are you guys able to see the install Anaconda? Just making sure.
I don't see anything in the chat. I think we just can simply ask them.
Okay then. Yeah, so if you are able to see this, then we're going to continue this. So if we check the README, you'll see that the Excel web packages are included in the installation. So you got an Icona Navigator. It's gonna have the libraries that we'll be using also. So let's go find. So we got Jupyter Notebook. Sorry, I just found it. So we got Matplotlib. We've got we got NumPy. Got Pandas.
Sneha, we are only able to see the slide which you have showed as Jupyter Notebook.
Oh, okay. So yeah, that was what I was wondering about because
You need to progress to the next one if whatever you have, right?
Okay, yeah. I don't know, because I'm showing a different browser, so I wasn't sure if you guys could see it.
Maybe stuck somewhere. You probably want to refresh or.
I can stop sharing. I'll start sharing again. That's all right. Share screen. Are you guys able to see it now?
Yeah, we are able to see now.
You can see notebook. Yeah.
Okay. Yeah, so what I was just showing before was what packages are going to be included in the installation. There's, I'd say, like over 250 and more that they've given. I'm just going to show what we're going to use. So we're going to use Pandas. This is the version. We've got NumPy over here. Matplotlib should also be here as well. There's also Python because that's what we're coding, what language we're coding in. Yeah, this is the Python version 3.9.7. This is the version Anaconda seems to work best with, I guess. And then there's also Scikit-Learn, which contains basically most of the most popular machine learning algorithms. So we're gonna continue. If you want to keep looking at other packages, you can do that. Well, we're gonna continue. This is the license, so we can continue and agree, and we can install this. So we will allow. Well, because I already got Anaconda installed, it's throwing me this error saying it's already installed. But if you haven't got it installed, then just keep waiting. And yeah, so this is where it ends. So yeah, since it's already installed for me, it's gonna say it's failed. But yeah, if you haven't installed yet, just continue doing it. So I'll just wait for a few minutes, like 1 or 2 minutes, to get everybody set.
looks like they're in the progress of the different people are trying to do at different speeds, and hopefully they'll put it back in the chat saying, I did it, and so on.
Oh yeah. So it'd be good if you like put in the chat once you're done installing. That'd be good for me to know when to go to the next part.
And any one of you can post if you have a problem in in the steps that she's talking about, so that she knows where you are stuck. She can help you out also.
Oops, sorry. So I think I can, yeah, I'll go to the next part.
It may be a good idea for you to wait. If they need to use it. I mean, you can explain, but they still will be going through and
True.
hear the words rather than see the screen. And I'm not seeing anything that they're saying I have a problem here, etc. I recommend to the attendees, say something saying, done in the process, so that she can get an understanding of where you are.
Yeah.
Because I don't see any response from anyone yet. It may be taking time for them to, download and so on also.
Well, yeah, I think one person has their hand raised, so I'm assuming they're done. Not sure about the others though.
Yeah, you can continue, Sneha. It's okay if any queries, they'll post in the chat, okay?
Okay. Yeah. So now in order to access Jupyter Notebook, what we're going to do is we're going to open our terminal. So on a Mac, you can do command spacebar for like search.
Sneha, I think you're sharing the same PPT slide. You have to share.
Oh yeah, this is not part of the slides. It's outside. So if we go to terminal. So are you able to see this then, the terminal?
Yeah.
Oh, okay. Yeah. So in order to access Jupyter Notebook, all we're going to do is type the word Jupyter Notebook. All right. Yeah, so this is what opens up. It's going to show this link. This is where the host is at 8889. So now if you want to create a new Jupyter Notebook, so where we code, let's first start making a new folder. So let's go to, we got the new folder, and I got my entitled folder here. Want to rename it something better, like call it GAIC Machine Learning Workshop. Because then it's easier for us to access our notebooks when we put it in folders. Makes it more organized also. So now, because I made my new folder, we're going to make our notebook. So since it already shows the version of what the Python version we're going to use for a notebook, because Python 3 is what we installed. So this is how a Jupyter notebook looks like. Just gonna quickly rename this. So what you see right here, this is called a cell because you can split your code into multiple of these blocks called cells. So they are basically independent of each other, so you can run each cell on its own without running the whole program at once. So what I mean by this is, let's start with this simple example. So print is already, you don't have to import any packages. So what we're going to do is we're just going to print hello world, right? And if you want to, let's add another cell. So in order to add a new cell, we'll just click plus, maybe say, welcome to this workshop. These two are independent of each other. So if you just run this cell, it's only going to output hello world. So in order to run this cell, you can just click this button run, or if you want another faster way would be on a Mac, you can do command return. So you have to press both buttons at the same time, and it will be like this. For PC, it should, like Windows, it should be about the same. It should be like Control Enter. It should be something like that. Yeah, so here it only prints hello world, right? It doesn't print this out, right? Same thing goes for here. It only prints out this part, but it doesn't print out hello world. So what you see is that these two, they're splitting the code into different parts and they're running independent of each other. So this is independent of each other, but there are cases where, you have variables and you're going to be using them in multiple cells. So what you have to make sure that the cells that have something in common, a common variable, a common data structure, they're all run before your current cell is being run. So I'll just give you another example. Right. So let me delete these. So let me just take out this. Right, so if you have a variable, right, x equals 5 and y equals 6, and then you have another variable in the next cell, you're like, okay, I want z to be equal to x plus y. So if you don't run this cell here, you just happen to run this, well, it's going to throw an error, right? It's not going to print out, well, what is 5 plus 6? It's 11. It's not going to print out 11. It's going to throw an error. So let me show you. I'm going to run this right here. Yeah, it threw an error because it believes that x is not defined, but it's already here, right? Like, why is it throwing an error? Well, that's because you never ran this cell, so it doesn't know that x exists. So you have to make sure that the cells before it are already run. So if I'd say I recommend usually make sure to run all your programs at once. So then it's easier for us to not get like confused about what's going on, and then we can debug easily. Right, so I'm gonna run this one first, and then I'm gonna run this. And I want to print out what z is. So let's run this. Yeah, so you'll get the answer is 11 now instead of an error. So yeah, what I just showed you was just making sure, like, make sure to run the cells before running your current cell, like with things that are in common. Here, yeah, in this example, there were no packages involved because creating a variable or just printing out a message doesn't require to import anything. So let's try a different activity. Oh yeah, also before this activity, if you don't want to use Jupyter Notebook, if you have something else you're interested in, there's also something called Google Collab, very popular also. I'd say the difference is Jupyter Notebook saves its files in your Finder, or in your folders. So if we go to your Finder here, so I know I had my stuff here. So my home is Muppalla. I have my folder here that I created just a few minutes ago, JIC Machine Learning Workshop. And this is my notebook. So this is where it saves my Jupyter Notebook, right? Even if I change like the name of it, it's going to like workshop, something like that. It's automatically going to change it. It's very cool. Yeah, so this is where Jupyter Notebook saves its files in notebooks. Yeah, so if you want to go to do Google Collab, it saves its stuff in your Google Drive. Mainly because, you know, it's it's from Google, so it's gonna be saved in Google Drive. But when you make a new Google Collab, you can't just like create a new Google Doc. You can't just click here and click new Google Collab notebook. So you have to like search it up sometimes. Like in this case, you can welcome to Collaboratory. Yeah, so I already have a few of my. I already created a few of my own Google Collab notebooks. But if I want to create a new notebook, and go to File, New Notebook. Yeah. Also, if you have like a Chromebook, I'd recommend using Google Collab. It's also pretty good too, because for Chromebooks you're not able to install Anaconda because it does not provide for Chromebooks once you have Linux. Yeah, so if I call this, and also the same thing, workshop. So yeah, it basically does the same thing. It has cells. You can run it the same way as Jupyter Notebook. The only difference is it saves on Google Drive instead of on files. Yeah, so if you want to access Google Collab, you can just log into your account. And then you can just search up Google Collab on Google, and it should automatically show up. Like I'm not sure if I can share a link for this. But yeah, I'll just give you the same example I did before. X equals 5, y equals 6. Create a new one. C equals x equals y. Print. Oh, okay, yeah, I guess, yeah, it works. I'm gonna same thing, you can do Command E. And if you want to run all of them, you can just go to runtime and run all. So that's pretty neat also. Yeah. So I was just showing you a bit of what Google Collab was. Yeah. And Jupyter Notebook. Yeah. So this example did not require any packages. So we're going to try a different activity where we are required to use we're required to import a package. So like just say I want to print out 10 random numbers from 0 to 100, right? So in this case, since we want to print out random numbers, we're gonna have to use a random integer method, and this will come from the package random. the random package. So all we have to do is, let me delete this example. I'll leave it out. I'll leave it here. I'll create a new cell. So we can import random. So that's how you import the package. And then, yeah, I'll create actually a new cell. So for I in range 0 to 10, 0 to 11 because, sorry, 1 to 11 because 1 is inclusive and 11 isn't inclusive, right? Because it's from 1 to 10. So in order to rank it from 1 to 10, you have to make sure that this bound is on part of it. So that's why I'm going to 11. Right? So if I want to print random dot, and if you want to see what methods a package has, you can click on tab. Should click on tab here. Sorry. Usually shows. Wait, sorry, I have to find this. Yeah. So when you click tab, it's gonna show like what methods you can use for this. So let's see what random has here. So it's got choices. Oh, okay. So it has this method called Randint, right? Let's see what else it provides. Does it give anything else? Okay, oops. So I don't think it explains what parameters it has, but we do know that we want it to be in the range from 0 to 100, right? So we're gonna do that. And let's see when we run it, it should, yeah. It prints out 10 different numbers from 0 to 100. Let's print out on. So we want to know what number this random number is, right? It's just like, okay, yeah, we got our 10 numbers. Very nice. Also, if you feel like the name of the package is maybe too long and you don't want to keep writing the word random dot method name, you can import random as whatever name you'd like to. Like you can write Bob or whatever you want. If you want to keep it short, we can try R, right? But yeah, so if we don't even run this, it probably will still work because this is the actual name of the package, right? So if we do R, however, it's gonna throw an error because we didn't execute this cell. Let's quickly do this. Yeah. So this is just an example just to how to import a package on Jupyter Notebook. Yeah, I'll just do the same thing as well on Google Collab. Yeah, so import random, right? Alright, Google Collab automatically shows packages. It's quite nice. So, right. Yeah, so you don't have to click on tab or anything. I guess it automatically shows the methods. That's where you need. Yeah, so Randint from 0 to 100. Yeah, it does the same thing, right? Yeah, if you want to write it from 1 to 10, just move these up by 1. Yeah, it's pretty cool. If you want to write it R. Yeah. Okay, so I just gave you like just how to get used to Jupyter Notebook in Google Collab, how to import packages, make sure to run all your cells, all of them, so you don't get confused, how to debug or get confused about what errors are happening. So we go back to our slides. So now that we got a basic understanding of Google Collab, Jupyter Notebook, and how to use them, we're gonna start going over our algorithms. Oops. So we're gonna start with decision trees. Yeah, before we go over decision trees, I just want to give you just explain what algorithms are. So if you have lots of data and you want it to get a result, you're obviously going to follow a list of instructions for a result to come out. For example, if you want to bake a cake, right? The data here is going to be ingredients like eggs, flour, milk, butter. And these are some of the ingredients used to bake a cake, right? So this right here is the data. And the output is obviously the cake. So in order to get from these ingredients to the cake, you need a recipe. You need a list of instructions in order to get to the cake. So these instructions or the recipe, this is what we call the algorithm. It's a list of instructions to get from the input to the output. So this is exactly what machine learning does, right? It takes in this ball of this data of these images of bunnies and dogs, and then it puts it into this machine learning model and algorithm. Using this algorithm, it's going to give out a result of whether it's a dog or a bunny. Yeah. So our algorithm we're going to use is decision trees. So decision trees, maybe by the title you can tell that the algorithm is going to work like a tree. So here's like an image of a decision tree of how it works. You have the root node. So when you put in an input data, it is going to look at this decision. From this decision, it's going to check whether it is a yes or no. And if it's yes, it's going to go to the right to the decision node, the blue one here. And then you got the left one if it's a no. So you've got the root node, you've got more decision nodes, and you've also got something called the leaf node. So leaf node is where you reach a final output. It's where you finally figure out what this image is showing. Is it showing a dog or a bunny, or should I keep continuing working on decisions? So if you see here, you've got this tree has it has about 4 layers, right? You've got the root node, you've got the decisions here, and then you got leaf nodes and the decision node, and you've got a final layer of leaf nodes. So this right here is 4 layers, or you can say a depth of 4 also. This is just another example of a decision tree that we use just like in a normal day. Like if you want to go to the market, you're first going to think, are you out of shampoo? If you're not, then you don't have to go to the market. If you are out of shampoo, then you're going to go here and you check outside. Is it raining? If it is raining, then you don't want to go to the market. You probably just wait and maybe go next week when it's not raining. And if it isn't raining, then it's probably a good time to get some shampoo at the market. This is just an example that we usually do every day. So this right here looks kind of like an Excel sheet, right? It's got the rows and columns, and it's got a lot of data right here. But this here is, if you see here, you got something called attributes and the classes. So we can also call these something else. We can call this the input data, which is the attributes, and the output data, which is the classes. Because based on the gender, the car ownership, the travel cost, and the person's income level, we can see what type of transportation they usually use or what they're going to be using, right? So we're going to have our decision tree model take in these attributes and result in this output of what transportation they're using. So yeah. So what I have here is two types of decision trees of the model of a decision tree. So one of them starts off with the root node as what type of travel cost, what is their travel cost like? And the other one is what is their gender? So I want you to see which decision tree is the best one to use. And how do you know it's the best? Well, you want to make sure that the number of layers is as small as possible. So you want the optimal decision tree. So I already split up the data into their sections. So you already have the cheap given in the side, standard here, expensive, and then the male divided and the female divided. So I want you guys to figure out which choice is the best one to use and the optimal tree to use for this data set. I might give I'll probably give around 5 minutes. That's a good amount of time. So then you can bring out a paper and just figure out. You can also try drawing out the entire tree and seeing which one's the most optimal tree. So I'll give about 5 minutes. And once you have an answer, please put it in the chat. And also, if you'd like to, maybe even explain why you chose that choice. Okay, so I think 5 minutes are up. If you have any ideas or if you think you have final choice, you can put it in the chat. I don't see any answers right now. Probably wait for 1 more minute. Otherwise I can go over the choices. Okay, so if we look at these choices, let's start out with choice A, right? So if our travel cost is cheap, we'll see that the final output is bus or train. And the attributes are 0 and 1 for car ownership and low and medium for income level. So there seems to be 2 choices for each attribute and 2 choices for the output. So that seems it might need some more work. Maybe need more layers to find a final output for the cheap section. If we go to standard, we'll see that the only output given is train. So that actually makes it easier because if the travel cost is standard, then we already know that the output is going to be train, that the person is going to go by train. Then we're going to check expensive. And yeah, so this one also only has one output. It's the only output it has is that this person is going to go by car. Because even though the income level is a bit different, the only output is cars. So for standard and expensive, we only need one more layer, which is the output, right? We'll just have to output train for standard and car for expensive. And cheap might need a bit more layers to work on to get the final output. Let's go to choice B. So if we check choice B, we got male and female. If we go to male, okay, so the output here has 3 different transportations, but there are only 3 transportations. So it doesn't seem like anything really changed, and we might have to work on more layers. Let's also check female. This one also only has 3 outputs. So there seems to be that we have to work a bit more on choice B than choice A, because it didn't seem to change, figure out any patterns in this output. So we'll have to work on more layers for choice B than choice A. So it seems that choice A is the correct answer. Yes, so now that we got choice A, and we already know that these two already have train and car as their final output, let's try working on the cheap part of the travel cost. So why don't you guys take like 2 or 3 minutes just to finish this part of the tree, and hopefully you try to find the most optimal tree possible with the least layers. And then we'll discuss in a few minutes. Okay, so you guys got some type of tree working. So this is the tree that seems to have the most the most optimal tree. So since we already know that these two outputs are train and car, and for cheap we've got male or female, and if it's male, if we go back, we'll see that male already has bus. Is the only output for male here is going to be bus. So that's why we can just output bus once we get the gender of male. Then if the gender is female, then there's 2 possibilities for the car ownership, and then from there we'll get the final output of a train or a bus. So this here has 5 layers. If it's possible, there might even there could be 4 layers even, but for now there's 5 layers. So it's 12 o'clock. I think we can take a break right now, because then we can start with the demo after learning.
You want to suggest, Sneha?
Yeah, we can take a break right now.
Yeah, why don't you suggest how many minutes you want? A break for the people or you also?
5 to 10 minutes. Maybe like 5 minutes would be good.
Okay, 5 minutes, that's it.
Okay.
Okay, people will group back in 5 minutes, same thing with you.
Mm-hmm.
But I'll be here anyway, yeah.
Okay, cool. Okay, so I think the 5 minutes break is over. So now that we've learned about how decision trees work and what it is, we're going to apply this algorithm for our demo using actually the same data set. So in order to get this data set and download it, I've created an Excel sheet right here. So I'm gonna post this in the chat. So here you got the gender, you got the car ownership, travel cost, income level, and the output here is the transportation. So when I share this quickly, get the think of you, let's copy it. Okay. I sent it on the chat. Okay. So now with this Excel sheet, you wanted to convert it to a CSV file, right? Because that's how you're going to get the input data for your machine learning model. So in order to do this, you're going to go to File, and you've got, you see this section here in Download, and you're going to download it as a CSV file. So, right, it just got downloaded. So when you open it, okay, I'm not sure if you guys can see this. Let me stop sharing quickly. Oops, okay. Yeah, so when you open this on like a graphing browser or something, like an application, it's gonna look like this. So from the Excel sheet to this. It's got a lot of time. Yeah. So now that you got it downloaded, let's go to your downloads. You want to make sure that your CSV file is in the same location that your Jupyter notebook is in. So I know that I created my notebook in this folder. So I want my CSV file to also be in the same folder as my notebook. So I'm gonna put it in here. I want to rename it to maybe just transportation. Okay. So okay. Yeah, so this was the notebook that we've been using. So now let's start with our demo. So first of all, in order to read our input, we're going to use Pandas, right? So let me just delete all this. Okay. Yeah, so we're going to use Pandas. So what we're going to do is we're going to import our package Pandas. And instead of writing Pandas each time, we're just going to rename it as PD. And in order to get this data set, we want to put it as a data frame. So we wanted to read the CSV file. So to do this, we're going to do pd.read_CSV, and and our name, wait. So what's it called? It's called transportation CSV. Yes. Okay. So we can call it transportation.csv. So yeah, if it's able to execute, there are no errors are throwing. It seems it's working well. Fine. So we want to just see how our data frame is used. It looks like that. So we input the data as a data frame, and this is how the data frame looks. So it's very neat. It's got the input, the attributes, and the output, the transportation. And it's also got like the index. It's very nice. So we want to split our data frame into attributes and output, right? So we have to split it up into two different sheets kind of. So let's say our input, let's call it input data, right? So let's make a new cell. Let's just get the output here. Yeah, if you want to just see how a data frame looks, you can just type in df. You don't have to do print or anything. Now, in order to split it, we're going to do input data equals df dot drop columns equals so transportation. So right, so because we don't want to have our output column in our input data, right? So we're just gonna take this out. And when we check our input data, just to make sure, right? So now we just took out this transportation column. And all it has right now is the input. So gender, car ownership, travel cost, and income level. Now, let's get your output data. Actually, yeah. So output data is just going to take in the transportation, right? So we can just take in this column itself. So df of transportation. Just to make sure we can see what it outputs. And yeah. So it seems out that we were able to split our data into two parts. And we're able to, using the input and output data, we can put this into our model, decision tree class of our model. Okay. So also, so when you have decision trees, you have to make sure that all the input is in numbers, because it's not able to, it can't run or fit the input data as other characters or words. So we have to convert this stuff into numbers, right? So instead of male, female, we have to have like male is 0 and female is 1. And then for cheap, standard, expensive, we'll have to make that like 0, 1, 2, or 1, 2, 3. So this is what we're going to use. We're going to use something called label encoders that converts these words into numbers. It's kind of like vectorizing. Yeah, so since Scikit-Learn, it has a lot of packages within itself. So we're gonna go from Scikit-Learn, sklearn dot pre-processing, because we want to pre-process our data, right? Because in machine learning, you always want to make sure your data is as clean as possible and in perfect use. So so label encoder. Okay. Wait, I'm gonna quickly stop sharing. I think I got the windows switched up. Quickly fix that. Sorry. Oh, sorry. Sorry about that. I was mute also. Yeah, there was some issue going on. But yeah, we want to convert our gender, travel cost, and income level to numbers. So we're going to use the label encoders. So we have the gender, travel cost also needs to do that as well, and income level. Right. So in our input data, we're going to change how our gender attribute is. Gender.fit underscore transform. Keep switching. Okay, yeah, so input data gender, right? So this basically, it converts gender into two numbers. Not sure why it's showing, wait. Probably because there might be a space or just a maybe additional space that could cause this to be a 2, but yeah, there's only there should be 1 for male and 0 for female. So we'll do the same for travel costs and income level. travel cost. And income level. Right, so now when we check our input data, now it's all numbers. So now our decision tree can now use this as our input data. So now we got our data processing done, and now we're going to be using our decision tree model. So let's make a new cell. And so from sklearn.tree import decision tree classifier, right? Okay, yeah. So let's call our model, our decision tree model. Let's just call it model, and we'll make it a new decision tree classifier. Now, since we got our input data as numbers and our output data also, we're going to do model.fit input data and output data. Yeah, so basically what we just we divided it into two sections of input and output. So yeah, our decision tree has been processed and it should work right now. And if we want to check a new type of a new person, like a new attribute, we can do like predict equals, so predictions, let's do predict model.predict let's see, model.predict. So we could try our own, but we have to make sure that the input is numbers. You can't write male, female, sorry, you can't write male, 0, sheep, or anything. You have to write all input here is numbers. So if we want it to be female, car ownership is maybe 2. Travel cost is, we want it to be like cheap, or actually we can make it with like standard, right? That would be 2. And income level, let's do medium maybe. Yeah, medium. So that's also 2. And let's see what it prints out. So okay, so it seems to print out train. Now let's just make sure this is true, because if we go back to our decision tree, which we've created, right, with the 5 layers, let me just quickly write down what we have here. So we have, so we have a female, car ownership is 2, travel cost is also 2, because standard, yes, standard, and it is, income level is medium, right? So this right here is our attribute, which is our input. Now our output here was train. So let's make sure this is correct. So we took female to standard medium. All right, because when you have your income level as standard, if your travel cost is standard, then it's automatically going to print train. So that's very easy when you have input is standard. So what if we try something like, maybe something more complicated? So instead of having standard or expensive, let's do cheap. Cheap might be a bit more complicated, but we'll see what happens. So cheap here would be female. So that's a 0. Let's do 0. Let's see what it prints out now. Okay, it's also train. So now if we have cheap, female to cheap medium. Yeah, so it prints out train, which makes sense. We can try just making sure that we have all the possible things. Just make sure. Okay, yeah, so this was just our demo. So just a brief summary. We use Pandas to get the data frame and store in the input. So we read the CSV file, and we have to make sure that the CSV file is in the same folder as our Jupyter notebook, because otherwise you can also locate the directory of where the CSV file is also, but if you put it in the same folder as your notebook, it's going to be easier to find and locate, and also easier to just put in as the name of the file. Next, then we have our input data. I just split up the data frame into 2 sections. One is where I drop the output column, I drop the transportation, and I keep the transportation column for output. Yeah, and then here I'm changing the words to numbers. I'm using a label encoder for each of these 3 columns, and you can see it changes to words. Sorry, it changes to numbers. This is where I'm applying the decision tree classifier. I'm putting in the input and output data, and I'm using my own type of data. I'm just checking what will it output based on the model and how we created the decision tree here. If you are not sure how your decision tree looks like, or it may be too overly complex, you can also just plot it down here. So you have to make sure from Scikit-Learn, you have to import the tree. So tree dot plot tree. You want my model. So fill equals true. Sorry, for Scikit-Learn. Okay. Tree. There you go. Gotta be careful about capitalizing true or not. Yeah, so this is how, if you want to see how your decision tree looks like, it's gonna look like this. But the thing is, it might be confusing what certain attributes you mean, how they're deciding what it's gonna look like, because you're not sure where the word train is, where the income level is, or words like that. It depends on the Gini, which is like the probability of errors occurring. X2 is like the input kind of value also. Yeah, if you want to see how a decision tree looks like based on your input data and output data, you can just type in this command and you'll see how it works. So here it seems that it actually has 4 layers. So this is less than what we have. So maybe we can check this out and, you can check it out on your own, see why it has 4 layers instead of 5. Okay, so that was our demo for decision trees. So yeah, that was like a basic understanding of machine learning basics. Yeah, and decision trees are a very well-known algorithm. It's part of supervised learning, where the input and output data are already given, and you're trying to determine from the model what the output is, and then you can compare it with the already given output. Right, so we can check out more advanced topics right now because we still have a lot of time left. So some advanced topics, especially deep learning. Deep learning is also a subtopic of machine learning, and it is very known to have better results than machine learning algorithms because they require more complex uses and stuff. So what I have here is CNN. It is a expanded, it's called convolutional neural network, and they're used for image detection, text analysis even, and they're used for a lot of things. Like for the case where I gave, like where you determine the image is a dog or a bunny, you can use your neural networks to divide the image into pixels, and from there it can determine what the image represents. Also a commonly used thing would be also recommend systems, right? So if you go to Netflix or like Amazon, if you buy like an item or if you go search for an item, it will show more items related to it. So if we go to Amazon, I'll just give you an example. Let's go to Amazon. We have some items here. Like if I want to find headphones, I like headphones, they're very cool. Yeah, so you got these cool items right here, like Beats, Apple earpods. So if we maybe check this one, it says bestseller. That means a lot of people bought it. So yeah, you'll have the description and stuff. You'll have what other products this company has sold, what they're giving out. They'll see what most people might have bought this with. They'll show other types of products related to this item also. So this is kind of like a recommender system. And in order to figure out how certain products are related to one another, or whether that user is interested, or like what they should recommend for that user, they're using machine learning for this. They're using another type of algorithm. It's called collaborative filtering. So you check multiple users, what they've bought other than this item, what's related to it, and what's the most commonly used products related to one another. And using all this data from other users, they're going to show the target user what they recommend for them to buy, what they recommend them to buy in the future also. Right? So this is just like for buying products, like for headphones and Amazon. So yeah, if you want to buy products, there's recommender systems. Netflix has it for movies. There's a competition also a long time ago that Netflix hosted for an improved recommend system, and the winner did use machine learning for that also. Also, if you want to go traveling, you want to see what you want to do when you're going to that location. There's Expedia. It is a well-known travel website. So if you're in the need of going to Hawaii, Hawaii, I'll just search it up, and yeah, look, you see by sort by recommended, right? What people have said before, what they've noticed from other people. They're using machine learning to gather all this data. If you want to more travel, things to do. Yeah, so you'll see that a lot of websites related to travel or buying or what you're interested in, they usually try to find other things that they want the user to buy as well, right? So they're going to recommend you things that will get you interested to get those, to get that item or a movie or, whatever you're interested in. Another thing after the recommend systems, that was like an example of where machine learning is used, and will be used in the future also. Yeah, another thing is there are other machine learning algorithms out there, right? Decision trees is a well-known machine learning algorithm. There are other ones such as logistic regression. This one is actually very, it does provide a very high accuracy when the output is based on binary classification. So what I mean by binary classification is the output is either a 0 or a 1, right? Like is the picture is either a bunny or a dog. And you can easily figure out this output very good. It will provide very good results and a very high accuracy. Random forest, it's another machine learning algorithm. Simpler terms, it consists of multiple decision trees. So you have the decision tree and you have a multiple decision trees. This is very helpful because it does provide better accuracies than a decision tree because it leads to more binary figurative decide which one's better, but it does require a lot of data checking, because for decision trees it doesn't really matter how large the data is, because the amount of data doesn't usually matter for decision trees, but for machine learning algorithms and neural networks, it's really helpful and it will provide more accuracy when you have larger sets of data. Another thing is NLP. NLP is like natural language processing. It's very useful for text analysis, sentiment analysis of lexical content of articles. If you've noticed, there has been a lot of machine learning works related to fake news also. Yeah, they usually use NLP or logistic regression and neural networks for like fake news also. Yeah, so these are some of the advanced topics that you guys can start learning about after what you've learned from the basics of machine learning. Yeah, so that's basically it for my workshop. Yeah, so after this, yeah. Yeah, thank you for listening.